All right, hello everybody. Welcome to our next video for Unit 2, which is polynomial and rational functions. Today we are just reviewing a skill that you guys learned in Algebra 2, and that is how to make an equation from a graph of a polynomial. All right, this should be kind of a quick video, except the very last thing is kind of tedious and you won't like it, but we're gonna do it anyways because I think math is fun. Sure, cool. Okay. Let's just get into it. All right, so here is a polynomial function on my graph. I know it's a polynomial because it looks like one. That was so helpful. But it does look like one, right? So it has that kind of mountainy shape to it, right? So it's a polynomial. All right, so what I want to do is I want to take this graph and I want to make an equation that would work for this graph. All right, to do that, the first thing I need to do is find the zeros or the x-intercepts of this function. So looking, I see that I have 1, 2, 3 x-intercepts. All right, now these intercepts do have different multiplicities, which we talked about in our last video. All right, hold up, hold up. What would you do? It's late at night, guys. I'm going crazy. That's fine. I'm just singing to myself. It's totally normal. It's totally normal. Okay, here we go. So we have our 3 zeros that do have different multiplicities. So when we write out our zeros, I also want to mark down what the multiplicities of these zeros are going to be. All right, so starting from the left, I hit -3. So my zeros, first one I get to is x equals -3. Now, because my graph goes straight through this point, I know that it's going to have a multiplicity of 1 because it's going straight through. All right, excellent. Moving on to the next zero, I have -1, 0. So -1 is another zero of my graph. Now, based on how my graph is going through that point, I know that this is going to have a multiplicity of 3 because I have that nice like wiggle pattern. All right, so this is going to have multiplicity of 3. All right, and then my last zero is 1, 0. So I have 1 as one of my zeros. All right, and based on the way the graph looks at this point, I have that nice parabola shape or that bounce. So this is telling me that I have a multiplicity of 2 at this 0. So multiplicity of 2. Boop-a-doo. Excellent. Now, the next thing I'm going to pull from my graph is my y-intercept. Now, if your polynomial has a y-intercept of 0, 0, you're actually going to need to pull a different point from your graph. But since my function has a y-intercept that is not at 0, 0, I'm going to be able to use that to make my equation. All right, and my y-intercept is right here at 0, -6. Okay. Now, we can kind of get this into factored form, kind of. We almost have enough information to put it fully into factored form. We can at least get the factors themselves. All right, so just in case you might have forgotten how to go from a 0 to a factor, all you have to do is take each piece. So like we have x equals oops, I meant to do 3 first. X equals -3. We also have x equals -1 and x equals +1. All right, so to get them from like intercept or 0 form into factor form, all we need to do is move everything to one side of the equation so that it's equal to 0 again. All right, so for the first one, x equals -3, I'm going to add 3 to both sides to get x plus 3 equals 0. This is a factor. So now I have put that intercept into factor form. All right, next one, I have x equals -1, same deal. I'm gonna move the 1 by adding it to both sides, and that's gonna give me x plus 1 equals 0. So x plus 1 is another factor. All right, and then last but not least, I'm gonna subtract 1. Oops. So I have x minus 1 equals 0. So x minus 1 is my other factor. OneNote just force quit on me. on my iPad. So now we're just gonna wait for it to pop back up. I'll pause the video so y'all don't have to wait with me. Okay, I think we're back. We're recording again. All right, cool. Yeah, I just had to restart my iPad. It just wasn't working. So it don't matter. We got it to work now. We have x minus 1 equals 0. So x minus 1 is my last factor. So I can kind of go ahead and, like I said, I can kind of put this into factored form. So I have y equals x plus 3. Now I did leave a space for a reason, and we're going to talk about what's going to go in that space in a second. So I have x plus 3. Now this 0 had a multiplicity of 1, so I can put a 1 right there, or you can leave it off. You really don't need to have the 1, but it's a good placeholder while we're kind of trying to get this equation set up. All right, my next factor is x plus 1. And that had a multiplicity of 3, so I am going to put a 3 as my exponent for that factor. And then my last one is x minus 1, which had a multiplicity of 2, so 2 is the exponent for that factor. Now, we are very close to being done with the problem. The only thing we have left to do is figure out what goes into that blank right there. That's going to be our leading coefficient. Now, if you look at it above, it says leading coefficient A. So A is like the standard symbol for the leading coefficient. Like if you look at quadratics, we have ax squared plus bx plus c, like A is our leading coefficient. So A is typically your standard like leading coefficient letter. And that's what we need to find. We need to figure out what this leading coefficient out front is going to be for our polynomial, right? There are a lot of polynomials that have these 3 factors, but depending on the leading coefficient, that's going to determine how high my different parts of my graph are going to go, right? It's kind of like my dilation, right? So I need to figure it out. To do that, all I have to do is use my y-intercept point, because that gives me an x and a y value that I know should work when I plug them into my graph or into my function. All right, so if I have a 0 for x and a negative 6 for y, and I have this a out front, then a becomes my only variable, and that lets me be able to solve for it. So that's what I'm going to do up here. So remember, 0 is my x, negative 6 is my y. I'm just going to go ahead and I'm going to plug it in. So that gives me negative 6 equals a, remember we don't know what that number is, parentheses, 0 plus 3, 0 plus 1 cubed, and 0 minus 1 squared. All right, so I'm going to go through and I'm going to simplify. So negative 6 equals a, 0 plus 3 is 3, 0 plus 1 is 1 cubed is 1. And then 0 minus 1 is negative 1 squared, which is positive 1. All right, now I just multiply. 3 times 1 times 1 is 3. So this gives me negative 6 equals 3a. Divide both sides by 3, and I get negative 2 equals a. So that's the number, that's my leading coefficient that's going to go out front. All right. That's it. I am done with factored form. So now I have my equation for my function. Now, if your function has a y-intercept of 0, 0, to do this, you do have to find another point on the graph. All right, generally it's going to be given to you with the one for tonight that you have on your homework that you have to find like where you have 0, 0 as your y-intercept. I've kind of given you that other point on your graph that I think would be the helpful point to use. So just make sure that you realize if it does go through 0, 0 for your y-intercept, you have to find another point to plug in for x and y. But everything else works exactly the same. Now, that is factored form, but that is not the end of this problem. It does want you to go ahead and take this and put it into standard form. And I'm not trying to be funny. You guys are going to hate me for this. But we do need to practice getting something from factored form to standard form. It's not the worst thing ever, but it's pretty close. It's just a lot of multiplying. All right, because basically what we have to do is we have to multiply this whole thing out. All right, so I'm going to go ahead and kind of do this off to the side. So I'm really going to like move everything over, kind of zoom out a little bit. All right, and I'm gonna go, oops, I didn't mean to use the eraser. All right, so first thing that I'm going to do is go ahead and write this so that it's kind of all the way expanded. So -2 times x plus 3, x plus 1 3 times, and x minus 1 twice. Okay, so now that I have that, I can kind of move all the way over. So I literally, guys, we're just multiplying this straight out, literally multiplying it all the way so that we have no more factors left into our problem. All right, the way that I like to do this is I like to group things that are the same because that's just a binomial that's been squared. I could have left it like that if I wanted to, but I didn't. But I can still do those multiplications really quickly. So again, I have that x plus 1 times x plus 1. I know how those factor really quickly, so I'm going to go ahead and put those in. So x plus 1 times x plus 1 is x squared plus 2x plus 1. X minus 1 times x minus 1 is x squared minus 2x plus 1. All right. The next thing I'm going to do is I'm going to go ahead and distribute that -2 into that parentheses so I don't forget about it, because that's something that I tend to do. I forget about the number out front. So I'm just going to go ahead and put it into that first parentheses so I don't forget about it. So -2x minus 6. And then the last thing that I have is that x plus 1 right there. Okay, so this does look a little bit better. All right, I took 7 pieces and now we're down to 4 pieces, so that was helpful, but I still need to do more. So the next thing I'm going to do is go ahead and multiply these two together, and then I'm also going to multiply those two together. Now when I do this multiplication, I like to use a box because it helps me organize everything. If you like to just go ahead and just multiply all the pieces, that's fine too, but I would recommend using a box. So for my first two, I draw my box. All right, I have a -2x and a -6, and then an x and a 1. So I put my factors on the outside, and I'm just going to multiply to get the boxes on the inside. So -2x times x is -2x squared, -2x times 1 is -2x, -6 times x is -6x, and then -6 times 1 is -6. So combining like terms in my box, that's going to give me -2x squared minus 8x minus 6. All right, I'm going to do the same exact thing for the other two factors there, but I'm going to have to use a 3x3 box because those each have 3 terms. All right, so x squared 2x 1, x squared minus 2x 1. All right, so again, I'm just going to go through and I'm going to multiply. X squared times x squared is x to the 4th. X squared times -2x is -2x cubed. X squared times 1 is x squared. Moving on to my next column, 2x times x squared is 2x cubed. -2x times 2x is -4x squared, and 2x times 1 is 2x. All right, then this is easy. This is x squared minus 2x and 1 because it was just times 1, so that was easy. All right, so again, I'm going to go through and I'm going to combine like terms. Now this is nice because all the diagonals are what's going to be your like terms. So I have x to the 4th. All right, these two are like terms, so I can combine those. -2x cubed plus 2x cubed is 0x cubed, so that's really nice. All right, next I have this diagonal. So x squared minus 4x squared, which is -3, plus 1, which is -2x squared. These ones, that's nice, that cancels. 2x minus 2x is just 0, and then a plus 1. All right, that worked out really nicely. I wasn't expecting that, so I'm kind of pumped that it worked that way. Actually, I should have expected that because factoring, but it's okay. All right, next up, last but not least, I just have to multiply these two together, and then I will be done. All right, so I'm gonna make another 3x3 box. Oops, I did one less thing that I needed. That's okay. Negative 2x squared minus 8x minus 6, x to the 4th minus 2x squared, and then plus 1. Okay. Now I'm just going to go through and multiply. So this is negative 2x to the 6th. This is negative 8x to the 5th, 6x to the 4th, positive 4x to the 4th, positive 16x cubed, positive, that's not 8, that's multiplying, duh, positive 12x squared. This is negative 2x squared. This is negative 8x. This is negative 6. Okay, so now I'm going to combine like terms and I will get my final answer. So y equals, I have a negative 2x to the 6th, then I have a minus 8x to the 5th, then I have, oh, the 4's are right there, so that's minus 2x to the 4th. I only have 1 cubed plus 16x cubed. I have 2 squares, so that's going to give me plus 10x squared. Oops, I ran off the page. There we go. Boop. All right, and then I have a minus 8x and a minus 6. That, my friends, is standard form. Yes, it was beautiful. It was superb, freaking fantastic. It was actually quite disgusting, but there it is. All right, so good news, you don't have to do this a lot. Bad news, you do have to do it on your homework tonight. So yeah, so that is putting it into standard form. My advice, just group the pieces together, handle them, do your multiplication, and then hopefully it will work out pretty nicely. I think there's only one that's this bad on the homework. I think most of them are like something cubed as your highest degree, so they actually don't take that long to factor out. That one was kind of brutal. I apologize. But that is it for this video. So if that was helpful for you, great. If you didn't care about it, great. It's hopefully I thought it was helpful. If you do have questions though, remember office hours every day from 2 to 4, Monday, Tuesday, Thursday, and Friday. And on Wednesday, it's 10 to 12 and 1 to 3. All right, so I am available for you if you do have questions, comments, or concerns. All right, until next time, bye guys.